This is day 7 video. This is for Wednesday, April 1st, 2020. Today we're going to graph the log function. And basically the log function is the inverse of the exponential function. So just for a little review, we're going to take a look at what the exponential function is, looks like, and then graphically and algebraically, how do we get the inverse? All right, the exponential function, you recall, has two key features. It has a horizontal asymptote at the line y is equal to 0, and it has a y-intercept at the point 0, 1. It approaches to the left, the asymptote, and rises without bound to the right, and that's the exponential function. Of course, its domain, because the arrows are in both directions, will always be the set of x's such that x is an element of all real numbers. And if you choose to write it in interval notation, it would simply be from negative infinity to infinity. The range will always either be from the asymptote up to infinity or from negative infinity up to the asymptote if it were a reflection over the x-axis or the horizontal asymptote. So here we're going from 0 up to infinity. And of course, in set notation, that would be the set of x's. Nope, this is the range. That would be the set of y's such that y is an element of all real numbers. Alrighty, so the the logarithmic function is the reflection over the line y equals x, because that's what an inverse, how you graph. The line y is equal to x, the inverses will be reflections over that. So if you see here, this is kind of what our graph is going to look like right in here. But how are we going to get that? Well, remember, to do an inverse, you are going to interplace the x's and the y's. So if I got this single point here, x is 0, y is 1, that's going to change to x is 1 and y is 0. The horizontal asymptote becomes a vertical asymptote, not y being 0, but x equaling 0. And if I put in this line here to help guide me, I can see that the graph of the logarithmic function will look like that. And its domain is really going to be what the range was of the inverse. So that is always going to be from the asymptote up to infinity or from negative infinity up to the asymptote if this were a reflection over the y-axis. So the domain here is going to be from 0 to infinity, or again in set notations, the set of x's such that x is greater than 0. The range, well, the range is going to be what the domain is over here. So this arrow goes off to infinity in the y direction and down to negative infinity in the y direction. So that is going to be the set of y's such that y is an element of all real numbers. And of course, in interval notation, you can go from negative infinity to positive infinity. And that's the graph of the logarithmic function. Now remember, we've got the general form, y is equal to a log, I'll put a capital B down here for base. That's not this b up here, b times the quantity x minus h plus k. And we're going to find a, b, h, and k and do all of our transformations just like we did on every other function. Okay, so here's the first graph I'm going to do for you. Y is equal to negative 2 log, and I just made it the common log base is 10 here. You can make it 10, you can make it 5, you can make it 2. Really isn't going to impact our graph. We're going to look at A, B, H, and K and state what those transformations are, go through those transformations, and then go ahead and plot our graph. So A is the number in front of the function, which is negative 2. Negative 2 does two things for us. It's going to reflect, so it's going to be a reflection, so it's going to reflect over the x-axis. And since a is 2, the absolute value of it, positive 2, it's going to be a vertical stretch, so it's going to stretch it vertically. B is the number right in front of x here, so there's a 1. That does absolutely nothing to our graph. H is what is here, but it's not -1. It's always the opposite of that, so it's +1. And it's a translation to the right, 1 unit. And K is the constant added outside of the function, and you keep it the same sign, 2, and that is going to be a translation up 2 units. All right, just like I did with my exponential functions, when I graph my logarithmic functions, I'm really interested in two things and a quick sketch of the graph. I'm first interested in the vertical asymptote. Now, with the exponentials, the horizontal asymptote, the only thing affected was K. It's going to move it up and down. Well, this is going to move left and right with H, so what I have is my vertical asymptote has simply translated 1 unit to the right, so X is equal to 1. It's that simple. The vertical asymptote will always be H. The point 0, 1, I'm going to run through these transformations and come up with where that point was and use my knowledge of the parent function to graph this. All right, so A is going to affect Y. It's going to vertically stretch it and reflect it. That's going to affect my Y values, and I'm going to multiply the Y times a -2. So that point becomes 0, -2. Now that does two things in once. It reflects it from 0, 1 down to 0, -1, and then stretches it by a factor of 2 down to 0, -2. B would do the same effect to the X value, but B is 1, so 1 times anything is itself, or 0 times 1 is 0. So it doesn't matter, it doesn't change it. H and K are translations. It's just going to add units to it. So if I'm adding to the right or left for H, I'm going to add to my X. So I'm going to add 1 here, so that becomes 1, -2. And the last transformation is going to be K. K is going to be added to Y. So I'm going to add a 2 to Y here, and that becomes 1, 0. So I'm going to go over 1 and up 0, and that's impossible. So what did I do wrong here? So I've got my 0, 1. Oh, that's what it is. I did not have a 0, 1. This is not a exponential function. I started with the point 1, 0. This is a logarithmic function. My apologies. So I'm going to take and reflect it, or reflect it and stretch it in the vertical direction. So I'm going to multiply this 0 by -2. That's going to be 1, 0. And then I'm going to take the 1 and multiply it by the X value, which doesn't do anything, so I'm not going to change anything. H is going to add to the Y value, so I'm going to add 1 to that. That's going to be 2, 0. And I'm going to go up 2 units, so I'm going to add 2 to Y, and that's going to be the point 2, 2. Okay, let's see now what we have over here. This is 2, 1, 2. Here's my point. And this is a reflection about the x-axis. So my parent function of the logarithmic looks like this, but I have to reflect it, so it's going to be coming like this. Okay? So my domain for this is now going to be from the asymptote up, so the domain is going to go from 1 to infinity. And my range is going to be the set of y's such that y is an element of all real numbers. Sorry for that little mistake there with the exponential function point, but that's all I want are those two key features and then a quick sketch and the domain and range. And if I knew how to use this video editing software, I could have erased that out of there, but hopefully you'll forgive me. Here's the next one I'm going to do, the natural log of 2x minus 2 plus 2. Lots of 2's in there. Remember, this looks like h, and it actually is b, and that actually is b, but that is not h. Whenever we have a number in front of the x, it must be factored out to give us our proper k value. All right, now we're ready to list what a, b, h, and k are. And a, of course, is outside of the function, so it's 1. That does nothing to my function. No stretch, no reflection. B is a 2. That's going to be a horizontal stretch. No reflection, though. H is a positive 1. That's going to go right 1 unit. and k is 2. That goes up 2 units. So quickly graphing this, we're going to take that vertical asymptote and move it to the right 1 unit. That's what I did on the last one. I should have come up with something else. So x is equal to 1. I think I did a 2 there too. All right, now I'm going to start with the correct point. The correct point for a logarithmic function is 1, 0. So I'm going to transform that through these 4 transformations. A does absolutely nothing to it, so I'm going to multiply y by 1, so that doesn't do anything. I am going to multiply the x value by 2 for the b, so that moves the point to 2, 0. H, I'm going to move to the right 1 unit, so I'm going to add 1 to that 2. That becomes the point 3, 0. And lastly, I'm going to add 2 to the y to shift up or translate up 2 units. So my point is 3, 2. So if I come over here to 3 up 1, 2, it's way over here. So you can kind of see it's horizontally stretched. So it's going to come down here like this and approach the asymptote as it goes down towards negative infinity in the y direction. And all we need is the domain. So we're just going to start from 1 to infinity, the asymptote up. The range always the set of y's such that y is an element of all real numbers. All right, guys, check it out on Google Classroom. Ask me any questions you like. Have a great day. Talk to you tomorrow.